missed the first. So welcome everyone to the second forum on the environment and climate change Embrace the Earth has organized. My name is Kiki Trost. I am communications and network coordinator here at Embrace the Earth, and it is my honor today to introduce Dr. Assem Mohamed, who will be talking to us about circular economy in Egyptian agriculture. So Dr. Assem Mohamed is a senior economic analyst and currently serves as head of the Agro-Meteorological Applications Research Department at the Central Laboratory for Agriculture Climate, Agricultural Research Center, Ministry of Agriculture and Land Reclamation in Egypt. He holds a PhD in agricultural economics and brings over 20 years of expertise in climate change adaptation, agrobiodiversity, environmental economics, and sustainable development. Throughout his career, Dr. Mohamed has led and contributed to numerous multidisciplinary projects at national and international levels in partnership with organizations such as the FAO, IDRC, ARCA, and the German-Egyptian Research Fund. His research focuses on the socio-economic impacts of climate change on agriculture, climate risk assessment, and the sustainable utilization of agricultural resources and residues. He has published extensively in peer-reviewed journals, contributed to global assessments, and developed models for climate-smart agriculture and food security. He served as a lead author for the MED-ECC assessment report and was a fellow at the IPBES Global Assessment for Biodiversity and Ecosystem Services. Dr. Mohamed remains deeply engaged in policy-relevant research, promoting evidence-based solutions to enhance agricultural resilience and sustainability in the face of global environmental challenges. With that, I would like to hand over to you, Dr. Mohamed, and very interested in what you have to say.
Thank you very much, Kiki, for your brilliant introduction. So I'm going directly to my topic is circular economy in Egyptian agriculture. I'm going to present turning waste into resources, and I will give 3 examples, pure Egyptian examples about this, how to turn waste into resources. 2 examples for my Central Laboratory for Agricultural Climate. Already I'm working for Central Laboratory for Agricultural Climate, yes, CLAC. So we have 2 business model in CLAC and 1 business model as private sector. So the agenda for today is, my plan is sustainable. I'm going to present sustainable agriculture with the circular economy, sustainable development and circular economy, and the circular agri-food system. And then I will explain the circular economy approaches for agricultural products. And as I mentioned before, I'm going to present 3 business models. And I put also some references, selected references for further information if anyone wants to read it. And for sure, I'm waiting for your feedback and questions after I finish with my presentation. So sustainable agriculture with a circular economy. So the agriculture sector, for sure, operates as a linear economic model. This linear economic model creates food waste and greenhouse gases. So the agriculture sector already represents about 25% of GHGs. So the question is how we can turn a linear agriculture model into a circular economy. So if you just look to this photo, you will find this is one way to turn our linear linear model to circular model. So we already use this photovoltaic for the irrigation methods. So sure, photovoltaic actually this is a renewable resource of energy. So actually it's good for the decreasing or diminishing GHGs emissions in the agriculture sector. So we start first with linear economic definition. So as you see, linear economic model is based on extracting the raw materials and then make it and consume it, and after that disposing of waste in landfills. So as you see, take, make, consume, dispose, take, make, waste. So this is different definitions of linear economic or linear economy model. So linear model outcomes creates about 1.6 billion tons of food waste globally, and also creates 3.3 billion tons of greenhouse gases. And the linear model also outcome represent or create or represent about 30% of GHGs, or 25 or 30% of GHGs from this sector. So this is photo for rice residues. It's buried in the crop inside the field. So I guess, yes, we already solved the problem. I'm going to explain this point in further, but just keep it or remind this big picture, because we will talk a lot of this one. So there is some facts. Farmers sometimes utilize, not sometimes, actually it's always utilize harmful chemicals and practices to maximize crop yields. So the farmers often prioritize profit over environmental and health concerns. He never thought about these concerns, environment or health for people. He just think about profit. So from my opinion, if the governments give this farm a suitable profit, it's enough for expenses and his livings, I guess he can start to think about the environment concerns and health concerns for other people. Also, food processing often contributes to pollution. Let's say if we reduce food waste, actually we can reduce global emissions by 8 to 10%. One more fact, according to FAO, we have more than 820 million people don't have enough to eat, actually go to sleep night without food. So this is a big problem. So I guess if we just stop the waste or try to decrease or diminish this waste by a third or by half, I'm sure this is enough for people, or for 1 billion people to find suitable food. Sorry. So circular economy. I'm not going to talk about the history of circular economy, because it's too much to talk. Need more than an hour to talk about the history of circular economy, but I'm just giving some glimpses and small definition about circular economy. So the principle of circular economy is we just close the loops of the linear economy. Simply, we need to close these loops of the linear economy, so we don't need to find any waste. And also we can change, we can set these byproducts to adding value, okay, and generate additional, or maybe can be the second raw material for the second industry or something like this. Also, the principles of circular economy promote sustainability and also help agriculture sector to maximize profit by 3 items: meeting customer expectations, and also uncovering new opportunities, and strengthening supply chains and increasing efficiency. So the definition of circular economy simply is there is no waste regenerated from this anyway, the nature of materials or whatever we use, different goods. So we have maintenance, reuse, and remanufacture, recycling, and composting. This is simply CE definition or circular economic definition. So as you see, this graph shows the differences between linear economic model and circular economic models. So as we said, we have resource extraction, then reduce it and distribute and consumption, and then put it in landfill or the garbage. Circular economy, as I said, simply we need to close this, make a loop, sorry, to just take circular shape. So the production, distribution, consumption is the same items of linear economy, but actually we will replace this waste with recycle or reuse and just close this loop. So this is also one more definition for circular economy. We have raw materials and we product these raw materials and change to goods and services or goods, and then consumers buy these goods. And then we have waste hauling and waste facility. So waste facility going to landfill. So this landfill make the greenhouse gases. We can this landfill also it's a mega source of methane emissions. And if we just try to cut this linear, we need to stop on the waste facility and try to make it like chemical recyclers and go to raw materials, and we can use it from the beginning, very beginning also. On the other hand, we can reuse or recycling this waste facility to make a new products. Or also we can make this waste, or if you have maybe cell phone or your maybe some extra food, we can make a donation for this to another consumer. And actually this is kind of sharing is caring. So circularity had 3 goals: reduce waste and protect environment, and also reuse materials so they can be turned into something else of value. So sustainable development and the circular economy. So in the Summit Earth in 1992 in Rio, there is a Rio Declaration. So one of the most important, so this declaration have 27 goals. So one of the most important output of this Earth or Summit Earth is balancing, try to make some balance between environmental ecology and economy and society. So this is like pyramids. We need to work this pyramids, triangle or pyramids, okay, work triangle together. We need to work. Yes, we need to profit, but actually we have to take the consideration of the environmental consideration and society also. We need to take this in consideration. So we have 27 principles. Most of these principles, as you see in these arrows, blue arrows, focused on the environment. So this is a good start to protect, such as the principle number 4, we need to environmental protection in the developed process. Also, we need to, in the 7 principle, state cooperation to protect ecosystem. And maybe 17 is environmental impact assessment. And this is tools to use right now to take or to choose between the environmental projects. Yes, there is some more advanced tools such as life cycle assessment will work or replace with this one, but actually some environment or some society organization use this EIA also for the assessment. Okay, this is a sustainable, there is interrelation between sustainable development goals and circular economy. We all know the sustainable development or global goals already set in 2015, November 2015, and there is 17 goals, interconnected international development goals, started with no poverty and end with partnership for the goals. So you can find in the goal number 12, responsible consumption and production, target 12.2, 12.3, 12.5. Actually, this focusing on circular economy strategy and action plan. So in this sustainable development goals also they take the circular economy into consideration. Also, we can say about in understanding circular agriculture. Okay, circular economy works on different sectors, and agriculture sector is very important sectors, as we mentioned in the first slides, because we can use byproducts as raw materials for the different industry, and also we can close nutrients and energy loops. As I mentioned, we can replace this kind of energy with renewable energy. Yes, if you depend on the if you already use rainfall agriculture, it's okay. But in Egypt, we have only one source of water. It's Nile River, so we use irrigation. So irrigation needs a source of power. So we already use the fuel or gasoline. So we can replace this kind of fuel or gasoline with this renewable energy. So agribusiness also is responsible. So I mean linear economic, we already stay on, is responsible for climate change. As I mentioned, 30% of the GHGs come from the agriculture sector, and deforestation, about 80% loss of ecosystem. And we have land degradation and ecosystem service loss, biodiversity loss, freshwater use, and also pollution. Circular agri-food system. I always told the farmers we need to use best practice to get our goals, okay, such as we can cover the crops, make mulching, or we can just cover with any raw materials. We need to minimize tillage, no or low tillage, agroforestry, and we can make crop rotation. But I'm sure the farmers did not understand what I said. Not because he is an idiot or he didn't understand, no, because he need some subsidies. He need one which care about him. So this is kind of Egyptian farmers, by the way. If he just found the care or careful from the extension or the engineering or even professors or whatever, he will follow the rules. But he didn't follow the rules because I guess he don't have this much money to expend of his life expenses, to cover his life expenses. Second one is eliminating food loss and waste and creating value. 30% of a global food already waste or lost. So this is a big deal. We need to work on this kind of food loss or waste from the farm or even inside the kitchen. We need to make some practice to find solution for this one. And from my opinion, the donation is very good solution for how to protect our goods and fruits, maybe vegetables, even your clothes, even your old cells or whatever. Also, price promotion or offers also it's very good. Maybe you can buy 1 kilogram of particular goods and get or particular crops and get another one for free, or just you can pay for the people or the low income people, they can pay half of the price. So I guess there is the alternative solutions to keep our food away from this landfill. I'm going to talk about circular economy approaches for agricultural products. The main purpose of circular economy to minimize waste. Recycle the resources, regenerate natural system. Okay, if we try to make these goals, actually we will get reduces the environmental footprints, also enhancing efficiency and resilience of the agriculture system. Also, circular economy can help farmers be more profitable, and also it mitigate the impact of climate change. So this is kind of facts or glimpses about Egypt. Municipal solid waste generation is predicted to grow 2.1 billion tons in 2023. This is globally, by the way, from 2.1 billion tons to 3.8 billion tons by 2050. The waste problem is one of the most important environmental challenges in Egypt. Egypt produces around 100 million tons of waste annually from the agriculture sector, drainage, municipal waste in 2023. Okay. So this is kind of Egypt's agricultural residues. We can saw this is cotton stack and maybe the sugarcane stack and banana and rice straw. We have an estimated 35 million tons of agricultural waste are produced annually, around 70,000 tons per day. Yes, we can solve some problem of these residues, such as we have a great example or great experience and experiment of the rice straw. Maybe we solve this problem by 99% right now. We use this rice straw to make some, or this byproduct to going to make some industries such as paper or wood or whatever, etc., etc. Maybe feeds animals. So actually there is some, we find some solves. We solve the problem for some straws or some byproducts, and we didn't solve the problem for others. So this is photo shows the farmer in Egypt traditionally pile up rice straw and burn it, and it make a smoke. You know, this is black cloud. But now actually it's not as much as 10 years ago or 5 years ago. But these farmers actually, he already make this rice straw as a bale and sell it to other persons. But this is I don't know how he didn't have the ideas or technology to deal with this. So he just find one solution to burn it in his field without any, as I said, environmental considerations. So this table shows the example of residuous amounts in Egypt. We have corn straw, it's about 4.5 million tons, and this amount used as animal feed. Cotton straw, it's 1.6, and it's unutilized. Rice straw, 3.6. Almost 95 to 99% is solved, except this. At this point, we need to work on it. We need to make some extensions for farmers, how to protect the environment. Okay. Tomato waste, we have 1.1 million ton, actually is unutilized. Sesame straw and wheat straw, etc., etc. Wheat straw for sure is very expensive, and it's very profitable for farmers because they use this wheat straw for the animal feed. So this is a business model. Number one, vermicomposting. Okay. So vermicomposting under Egyptian condition is a great opportunity for maximizing the economical benefit of organic waste. We use these earthworms as biological machines and produce some valuable commodity. So vermicompost also is a valuable system for converting most of the organic waste into vermicompost. They're very rich and valuable. Organic vermicompost produce will assist in enriching the soil for sure, especially sandy and the newly reclaimed soil. This is general information regarding the utilization of earthworm in composting. This is our Egyptian trial. If we have 1,000 adult worms, the weight approximately is 1 kilogram. 1 kg of adults can convert up to 5 kg of waste per day. So approximately 10 kg of adults can convert 1 ton waste per month. 2,000 adults can be accommodated in 1 square meter, 1 by 1. Also 1,000 earthworms and their descendants under ideal conditions could convert about 1 ton of organic waste into the yield fertilizer in 1 year. So I guess it's a good numbers and deserve to try it. So this is a historical background. So I just choose the ancient Egyptian because this is Egyptian trial. So actually ancient Egyptians first to recognize the beneficial status of earthworm. This is Queen of Cleopatra, 1960 to 30 before Christian, said, earthworms are scared. She recognized the important role of the worms played in fertilizing the Nile Valley croplands after annual floods. So I guess this is a very, it's a nice word from this queen. So this is a circular use of resources. We have this garbage, this is food, and using by this worm, changing to vermicompost. This vermicompost used to fertilize the soil and to produce this food again. So I guess we need to keep and protect this food from going to garbage. I guess this also helps. So there's the different differences between vermiculture and vermicomposting. Okay, vermiculture is the culture of earthworms. We try to increase these worms to produce or to use it to eat more food and to produce vermicompost. On the other hand, vermicomposting is a simple biotechnological process of composting. Verm is the Latin Americans mean worm. So this is Latin America. And vermicomposting is composting with the aid of worms, in which certain species of earthworms are used to enhance the process of waste conversion and produce, for sure, better products. This is the principle of vermiculture. We have 5 basic principles to produce vermiculture: is bedding, food source, moisture, and aeration, and protection from temperature extremes. So this is the trial experience. We use 4 types earthworms. Actually, these worms start from our CLAC, from our Central Laboratory for Agricultural Climates. We already produced this one or brought this one from Australia, from Dr. Anna. And we start this kind maybe 2009 in Egypt in our Central Laboratory. So we use red worm and tiger worm and Indian blue and African night crawler. Okay. So bedding, actually bedding is a growing system. We already made it of brick with the dimensions 1 meter width and 0.5 high, 3 meter long and 0.5 between beds. The bottom of the beds was insulated by 20 centimeter. We can't see this one, and I will try to, yes, this one. So the growing system was made of bricks, as you see. Okay, with dimensions 1 meter width. Okay, this one, and 0.5 meter between beds. And also 3 meter long. Okay, this is 3 meter by 1 meter. And between this one and this one, 0.5 meter. Okay, this is cement layer with slight slope in order to facilitate collection of leachate. Okay. This is kind of food we already start with. It's a mixture of food wastes and shredded by this manufacturing or machine. This is a locally manufactured. We brought it from the motor planta in Egypt, and it's not very expensive for this time. So the temperature, the location of the ground bed was selected in order to avoid strong winds. So we use this location. It's a little bit far about the crack or lab, because this is we need to avoid strong winds. Shading roof made of reed mats. We already installed it in order to prevent direct solar radiation over the bed in the summer season. As you see, this is shading roof made from reed mats to avoid the summer or solar radiation in the summer season. So, and this is a product. Vermicompost is widely used in primary agricultural production. We already produce fruits and vegetables, mushroom production also, nurseries or parks or whatever. So we have two kind of products, vermicompost and vermiwash. This is a vermicompost and this is vermiwash. So as you see, this is our experiment. We make some paper, scientific paper about economic consideration of using different types of organic manure on the sweet paper yield under the protected cultivation. So this is our results. Actually, vermicompost was the top of the organic manure, and we make some economic consideration, economic indicators. So the benefit cost ratio, simple benefit cost ratio in the vermicompost was highest. It's 1.67, and the lowest one was in the cattle manure, 1.23. So this is, we have a lot of paper about this kind of, about this vermicompost, and all this paper affirms that the vermicompost is very good and very efficient and better than cattle manure and compost. Okay, so the conclusion for the business model one is all experiment indicated that the vermicompost is profitable enterprise with better net profits and better benefit cost ratio. Not only that, but also it's better for the environment consideration also. So this is a business model too. We already work on how to extract ethanol from rice straw. So this is our experiment. We designed the fermenter, which use this rice straw, shredded rice straw, and we extract some ethanol from this rice straw by this machine fermenter. So this is table shows the total investment costs for a small scale fermenter. We make some three small scales, 300 liters, 600 liters, 900 liters. And we will found that this one, 900 liters, is more profitable than 300 or 600 liters. And already we start to estimate the different costs for 900. We already stopped working with 300 liters and 600 liters. And we adopt this one, 900 liters, for the small scale farmers to work on it. So the cost of fermenter, about $1,600 US, and the administrative fees about $16.60. And direct costs is represent 4% of the total costs, about $66, and total investment costs was $1,750. Okay, and this is table shows the cost analysis. It's running costs for, or production costs for ethanol production from rice straw. I mean the third scenarios. We already work on third scenarios. So total cost of the total running cost, it was $1,143 to produce 20%. It's 20% extract to produce ethanol. Okay, the total return of for the third scenario was $1,720 20% extraction. We have 3 extraction, 15%, 17%, 20%. So profit actually is higher in 20% extraction. And actually we put some conclusion to advise small scale farmers to use or follow this one, ethanol extraction 20%, 9 liter capacity. And this is some financial indicators and recommendation for the farmer. And the present value and at discount rate of 30% was estimated to be positive value, about $1,000 US. PCR at the same discount rate, also 30%, estimated to be 1.22. Yes, it's suitable, it's not bad. And internal rate of return reached about 30%. And it's also okay as economic indicator. So we can also going to, so this first 2 business model was, as I told you, is government. And this is a private sector business model in Sohag. Sohag is in Upper Egypt, is one of the Upper Egypt governorates. And I like this business model because it's innovative. Okay, so this the objective of this business model is to try to change or to turn this waste of banana waste to the profitable products such as fiber production or wood or carton or whatever. So this is factory in Sohag, as I mentioned. But before we talk about this, let's say the banana production in Egypt. We have, I guess, in Egypt we have 27. Not I guess, it's true. We have 27 governorate. So I believe that this banana production is concentrated in the northern part of Egypt, like Alexandria, Beira, etc. We have 55,000, 27,855 fadan. And actually, sorry, we have 32,000 acre planted with banana in this place. And also in Upper Egypt, we have 18,000 acre planted with banana. And we total cultivated area was 70,000 and 325,000 acre with banana. It's not too much as mango or citrus, but actually it's okay. So unlike other fruits, we can find the banana palm takes 6 to 8 months to grow to maturity and producing one large branch. So the problem is one large branch. So the problem for this papyrus factories located in Sohag, they already the advantage of this factory, they established this one advanced with 500 acre of banana plantation, and this 500 acre plantation produce about 300,000 trees, bunch of trees. So this, I like this point because actually they save the cost of transportation, and it's easy to deal with this one, especially yes, it's only 500 acres, not too much. So I guess it's a good start for this factory. So you see, this is in this photo you can find this is the land of banana. So process of this of this factory, he want to produce veneer for furniture and musical instruments manufacture, and also molded products such as food containers and plates, liquid fertilizers, and garden peat. This is kind of food containers made from the banana waste. This is factory products, and also they produce this liquid fertilizers using in this with farmers in Upper Egypt. Okay, so also banana steams a fiber-rich opportunity. So I'm going to show you some international trials, how to use or how to benefit from the banana steams by making some fiber or some textile packaging. So this is fibers of the banana stems change to raw products and textiles and packaging. So this is in Philippines. So this is handcraft made of banana stem fiber. So you can see the circular approach offers numerous employment opportunities for the local communities. Also in Uganda, you can find the same trial, also same experiment. The banana farmers, by the way, Uganda is the second largest country to plant or produce banana, and the first country all over the world is consume banana. Maybe they consume 1 kg. The people or only the person consume 1 kg per day. If Uganda 30 million, so you can imagine a huge amount of banana already consumed by these Ugandan people. So you can find this one, the banana farmers in Uganda beginning to appreciate the new value of the West banana stems, and already they produce about 30,000 square feet of rugs each year. So this one is also, I found it in some particular website. This is guzur. Okay, guzur means roots in Arabic. So this is the final products for this. I don't know if you can guess which raw material or byproducts they can already produce it. Yes, this guzur is, sorry?
Sorry, I was going to say corn, maybe, no?
No, palm trees,
Oh.
yes. Okay, so these Egyptian handmade products from recycled palm trees west are marketed internationally right now. So this is online platform, launched in Egypt and around the world. So this is the website of Facebook if you want to buy any of this. I never saw but by the way, this is for women. This is women from Sharqiya Governorate. This is kind of empowerment of women to get and to work hard also. So this is select references if you want to read more. First one is what my paper about the agriculture, circular economy and agriculture and environment was published in Asyut magazine, journal magazine, 2018, maybe 7 or 8 years ago. And you can also read some this other references if you need more information. And you can contact me in my email or with my WhatsApp mobile, as it's you can see right now in the screen. Thank you very much for your time, and I appreciate your time. Thank you.
Thank you so much for that presentation. I think circular economy is so central to so many conversations nowadays, so it's very interesting to see it applied to Egyptian agriculture. Yeah, I want to ask if anyone in the audience has any questions to begin with. Otherwise, I definitely have one or two, and I'm pretty sure Katja will have one or two, but no, then Katja, go ahead.
Yeah, I have a question. That is, what are the main barriers to implementing circular economy models in the Egyptian agricultural sector? Oh, sorry, your microphone is off.
I said it's very good questions, and actually it's but from my opinion to answer this one, actually the mentality of the farmers need to change first to keep going on the circular economy in agriculture sector. We need both some policies. Actually, we have some lake of the policies to involve these byproducts in the circular economy. Actually, I mentioned before in my presentations, we need to involve the circular economy in our strategies and our policies. And it's not happening until now. But I'm sure we are going to work on it. And actually, maybe within a couple of 2 years or a couple of years, we will find circular economy working, because as I show you right now, the private sector already work, and NGOs already work with particular way, with very good ways in circular economy, and there is some also maybe national international organizations support of financial give financial for this kind of work. But I guess we need to start from all stakeholders, from the professors or maybe the research institute, and we need also to change the mind of the farmers, and even in the policymaker, we need to just show him what the importance of the circular economy.
I was also wondering, like, how do you envision circular economy within our globalized world, where, of course, a lot of the time production does not happen in the area where it is eventually sold? Like, how do we go about tackling that? Do you have any ideas about that?
So tackling what?
How to, like, do a circular economy within a globalized world where, of course, you know, not everything that is produced in Egypt will stay in Egypt, and not everything that is sold in Egypt is produced in Egypt, to stay within the Egyptian example. So how do we ensure a circular economy when we have to work with other countries?
Okay. So I'm sure if we start with our products firstly, actually we can make some cooperation between other countries. For example, Egypt is the number one of wheat export. We export about, import. We import about 10 million tons of wheat. So I'm not sure from Russia, from Ukraine, from USA, from France. I'm not sure what happened in the rice straw or wheat straw in these countries. But from my opinion, if we start locally, actually it will be easy to work internationally with other countries. It's not big deal, such as climate change. Climate change is globally, but need locally act. So I guess if we act locally in this circular economy, actually it would be good for other countries, especially for the people, because Egypt is number one in terms of orange export. We already export orange to 30 countries right now. So maybe if we use the pruning of orange and put it as a recycle, or we can recycle or put it in circular economy, I guess it would be good for the other countries. On the other hand, maybe we can use some, let's say, lesson learned from people, countries such as Netherlands or European countries, because they already have some or good techniques in the circular economy, and we can take this experience from these countries. We can ask cooperation by FAO or ICARDA or GTZ or whatever, and they can bring some experts in Egypt to make some sharing knowledge, or make some, or take even to learn from the lessons they already make in the countries.
Okay. Thank you.
Thank you.
Are there any other questions in the audience?
I have another question.
Yeah, go for it.
Well, maybe you already gave us the answer, but I would like to ask you anyway. What are the most abundant agricultural waste in Egypt, and what potential do they have as resources? Is this rice straw and the wheat straw that is the most waste resources that they are in Egypt?
Okay, 10 years ago it was rice straw. Wheat straw is very profitable right now, because the price of wheat straw is maybe it's expensive more than wheat itself. Okay, so there is no problem with wheat straw, but rice straw 10 or 15 years ago, it's a big problem. Just imagine if we burn about 3.5 million ton, only burn this huge amount. But now we use this. The problem is how to find the space to store these bales. We make this rice straw is in the bales, 50 maybe 1 ton or 1,000 kg. So they need huge space, and the farmers already don't have this space because we have small areas. Egypt, about 80% of the total agricultural area is small areas. It's 1 or 2 acres. So there is no huge place for store this kind of bales. But the government, Ministry of Environment and Ministry of Agricultural Resources try to find solutions and try to just pick up this rice straw and put some in another maybe far away places, or so just the transport costs was very expensive, but actually we need to protect our environment. We need to follow the environment considerations. So actually, from my opinion, or from the statistics, let's say, the fruit pruning, pruning this kind of trees come from fruits. This is a big problem. We have 1.7 million tons, million acre grow by fruits. So pruning, if we make pruning for orange or citrus or apple or whatever, so this is not using, maybe we can just ban it or use as a cool or whatever. So I guess this is a big problem right now.
Okay, thank you so much.
My pleasure.
Just as my last comment, thank you so much for this presentation as well. It was very brilliant, and I really like and appreciate that you are showing us in this last presentation 3 business model, and I think maybe many people can be benefit from this.
Thank you very much. I'm going to send you this presentation also by email.
Thank
Share
you.
it with our colleague.
Okay, thank you so much. Then with that, that was the second forum on environment and climate change from Embrace the Earth. Thank you so much again, Dr. Mohamed. Thank you for speaking twice as well. Thank you to all our other speakers and for everyone who attended any of the sessions. And thank you to anyone who is watching us back later. And yeah, I wish you a pleasant rest of your day.
Thank you so much.
Bye.
Thank you. See you. Bye. Bye-bye.